In this video, I would like to show you how to use Git to create and maintain a repository locally, that is on your hard drive. In this example, I'm using a terminal window on an Apple OS X machine. If you're a Windows user and you obtained Git using the sources that I specified in the notes section, along with that you will have gotten a bash shell emulation package, which would allow you to type in the exact same commands that I'm typing here. So if you're a Windows user, you can follow along as I'm talking and typing here. Okay, so I'm in my home directory and I want to create a folder that I wish to place under the control of Git. So I'll make this directory and I'll go there and I use the ls command. And it's hardly surprising that there are no files there. We don't have any of the files. And I'm anticipating creating a number of files here. Since this is just an example, these are simply going to be placeholder files. But in a real-world example, I would be creating code. Now, Git is language agnostic. It doesn't care if you're using SAS, SPSS, R, C, C++, Fortran. Name the language, Git will happily track it. The files do have to be text files, so it can monitor changes over time. That's why we're even wanting to use it. So what's the first thing I need to do? I need to tell Git, hey, I would like to create a repository. And the way I do that is typing git space init, press return, and I get a message back that tells me that Git has created a folder within this my project folder called .git. Now, if you remember from the previous video, I showed you that all these files that begin with a dot, or specifically the .git folder, is what's known as a housekeeping folder. This is where Git maintains its database. It tracks changes over time in this folder. It actually has a lot going on in there. As a newcomer, you should never touch this. There's no reason for you to attempt to edit any of these files here. So a first activity here, at least a reasonable first activity, would be to write or create a file. So I'm going to create a README file. This is common in software projects. You create this file to provide basic information. I am providing some basic info here. All right, this is just one line. And there's not much going on from the Unix point of view. We just created a file. There is a command, a Git command called git status that I can use, and it will show me what it thinks has happened. And what we have here, there's a number of messages here, and I'll get to all of them eventually, but for now the most important one is this one, untracked files. Git is telling me that, hey, look, I know that you created this file called readme.txt. If you want me to track it, then you have to use git add. And we'll go ahead and do that. So the rule, if there is one, or the best practice, is when you change a file, and creating a file includes a change. When you change a file, you want to acknowledge to Git that you've changed it. That way it will maintain differences over time. And let's look at what that means. Okay, I'm going to edit this file. Again, this is line 2. And if I type git status, it comes back with an interesting message. It says, look, you've staged this file. Some changes are waiting to be committed, but I'm also aware of the fact that you modified this file. Right? And that's why it's in red. It's kind of alerting us to that reality. So I want to go ahead and maybe re-add it. Okay, but before I do that, I want to show you something. There's a command called git diff, which will show me the difference between the first version and the second version. And this is where Git earns its keep. It shows us that this line number 2, was added. Okay, in this example, it's very basic, but imagine if you had a source file of code that maybe had 200 lines in it. It would be nice to know which sections of that file that you deleted or added. Okay, so it's very helpful to track these changes. So I want to go ahead and add this again. You can do the git status, and you can see we're sort of back to where we were before. Git saying, hey, you have some changes to be committed. All right, I'm not ready to talk about commit just yet, so bear with me. I want to make another change to readme.txt. So this is line 3, and then I delete line 2. If I type git diff, notice that Git is aware of the fact that I deleted line 2 and that I added line 3. So I'm trying to drive home the point that it's very difficult to get these changes without attracting Git's attention. That's precisely what we want. Okay, so I want to go ahead and add this to, I want to track that change. So I would keep doing this, okay? In a typical development cycle, I would keep editing this file until I arrived at a point where a certain level of maturity had been reached. So at this point, I would like to commit the change. And so committing is basically saying, look, this is ready to go, at least for now. This is like my version 1. Okay, so it's hardly a surprise that the command used to commit would be git space commit. And if I press return, it wants me to enter in a message. Now these messages should be meaningful. They should be helpful. Okay, so this is our first commit. This is version 1. Now you don't have to, you don't have to create version numbers unless you want to. I'm just using that here to make a point. So if I do that, we get some information back. You see this number. This is known as a hash. This is actually a unique number that's assigned to this particular commit. And over time, you could have hundreds of commits. And depending upon the size of your project and your development style, you could have thousands of commits. And so if we look at git status now, we see that nothing to commit, working directory clean. So this is Git's way of saying, look, everything is clean right now, and we would start the process over again. Now, we've just completed our first commit. We only have one commit, and you can see it here. It's still on the screen. There's a command called git log, which would allow us, let me clear this to make it more obvious. If I type git space log, I get the full commit number. This is something like a transaction number. It's unique to this commit, and if in the future we need to sort of look into the past changes, we can make reference to this number, or at least part of it. And you see that it contains the information about who did the commit. And in the first video, I talked about how to set your username. And it presents the date and time and the message that we used when we did the commit. Now we only have one commit at this point, so it's not particularly challenging to look at this. But once we've gotten a handful, or like 10 or 20, we want to find ways to improve the readability of this log, and I'll show you that momentarily. But let me add another file here just so we can stack up a few more commits. So the current status is that Git says, look, there are no changes to be committed, and we would continue our development cycle. So I want to create a file. I'll call it script1.r. This is a very simple, very trivial R file. Now again, Git is language agnostic. It doesn't matter that I'm using R. I could use any language here. And in this particular case, well, in the general case, I can type git status. Git tells me that I need to add this file for tracking. So I do that, script1, and I will now commit this. This is our second file. It is a program file. All right. And okay, we look at Git status, there is nothing to commit. So now if I type git log, let me clear this off again. If I type git log, you see that the oldest commit is here and the most recent commit is here. So this is how they start to stack up. Now there is an option, there's several options in fact, and I could elect to, or I could request that all the logs are printed on one line per commit, and this looks nice. It gives us the information about the commit number, and it also gives us the commit message, but the printout is dominated mostly by this number. So another alternative, and this is just something you learn over time, this is telling the log command that I want a formatted output, and these are what we call placeholders. These are tokens that we can use to parse only certain parts of the log. And I like this one. This is a pretty good one because it gives us the short version of the hash, and it gives us the date and time as well as the commit message. So this is how I might keep track of things. In subsequent videos we'll talk about how you might step back in time and look at previous commits and how to interact with that. To close out this video, I would like to show you how you can add several files simultaneously, or a collection of files contained in a folder. This is really easy to do. You don't have to add files one at a time. So as an example, I have these files in another location on my hard drive. And if you look at them, you see that there are 3 files, prog1 through 3. And I want to copy this folder over to my current project. So the way I would do this, or one way I would do it, is like this. So you notice that the folder code files is now present, and it contains the program files you saw earlier. So in terms of what Git sees, you notice that it sees the folder. It would also see the files contained therein. But all I have to do is say git add code files, and it picks up those files contained therein, and then I can just do the commit. Added code folder. Okay, so it's as easy as that.